So I'll just, maybe I'll show a couple more details on this stuff before moving on, rather than being too random with the 3D info command. Let me note, for example, for those of you that are not so comfortable with Unix, what that star.head means. So if we type, I type this 3D info, and I'll shorten it. I'll get rid of the O3. This star.head evaluated to match any file ending in .head in all caps. So all of these files, it's like we had typed these things. And you can actually stick an echo command, say, in front of this to just echo this text back to the terminal window, so it would see what it's like we had typed with that wildcard expansion. And it's as if we had typed all this garbage, 3D info prefix n4, and then Annapolis orig.head, and that TLRC head, all these head files. So it's as if we had typed all of that. Let me note that it might be, you can get things, info like the space of the data as well. So you see mostly orig and then some one TLRC for standard space. Again, here if you say space, it's not necessarily just TLRC for standard. Here TLRC actually means TaylorX space. You might see M&I, you might see M&I and NAT. If you define your own space, you could see that, I think. What other options does 3D info have? If you've set up your system fully like the instructions showed, you'll be able to see this, but maybe not. If I did 3D info dash and I hit tab, we've set it up where you get tab completion for options in the AFNI programs. So I hit tab after that dash, and I still see 3D info dash on the command line, but it showed me all the options. That's like file completion. If I type ls a and hit tab, it shows me all the files that start with A. It's similar to that, except with AFNI programs, 3D say deconvolve dash, I can hit tab, it shows all the options. So that's a helpful thing. If you know the option starts with stim something, you can hit tab, and now you just see options. Now you 3D convolve stim tab. Now you see options that start with stim. So that's very handy.
But it doesn't work like that.
So you have to set up set things up for this. So how many of you can see this? Just a couple of people. So if you want to set this up, you can ping us whenever, and we'll make sure that's working for you. But that is one extra step in the installation. So we babbled about the dataset headers, NIFTI datasets. NIFTI was a standard that was written or defined by many groups in combination: FSL, SPM, AFNI, I think Brain Voyager, I don't know. Anyway, a bunch of different groups. Many people came together to argue and bicker for a while. And they eventually came up with this format that's based on the old analyze format. But analyze, if that evil keyword is up here, I don't see it. Analyze format didn't have spatial information. You'd have your data set, but you don't know what is left, you don't know what is right, you don't know where it's located all the time. So it was a mess. So NIFTI was created just to be specific mostly about that missing information. Where am I in space? So NIFTI is a data format. Do we have the word NIFTI here? Oh, on top of the slide. Excellent. So NIFTI is a format that you can pass data among software packages via NIFTI format, because basically everyone can read and write. Some scanners can write NIFTI directly. Philips can, for example, I believe. How do you create NIFTI data sets in AFNI? basically any program can do it, any AFNI program. If you're using 3D Calc, 3D, any program in AFNI that creates a data set, you can say to make it called NIFTI. How? If you do 3D Calc, which is a three-dimensional calculator, if you want to add two data sets or divide by 3, whatever, if you take 3D Calc and your input data set is EPI, and you do prefix new, it's going to make new plus orig dot head and brick, right? AFNI data sets, but with the prefix new. If you said, say, dash prefix new dot NII, it will make a NIFTI data set, new.nii, or new.nii.gz, it will gzip, it will compress it. So basically any program you can say write as NIFTI just by specifying that in the output, okay? Getting and installing AFNI, you've all suffered that ordeal already. I guess we don't really have to say anything about that. AFNI at the NIH Scanners. I don't know how things are set up for you, but just it might be worth telling you what people do at the NIH. So particularly on the GE scanners, this has been set up for, I don't know, 10 years or longer now. I don't know, a long time, since iFiles, before Dimon was DICOM files were used. When the scanner starts, they have a little script to start. Well, let me be most simple. We have a program called Dimon, for example, that can look for DICOM files that are as they show up in the file system in some directory. It will keep scanning the directory and see them as they come in. Dimon will collect these images, these single slices, into volumes, and then ship those volumes to AFNI in real time, and you see them in AFNI, and AFNI will do like motion correction, and you'll see a plot of motion regressors. So even with this much, which doesn't take any setup, you can do this stuff. In the olden days, people actually would type Dimon and type AFNI on a different computer, and Dimon would run on the scanner, something that can see the file system from the scanner. And Dimon would send the AFNI images over TCP to a different computer, and you'd see them in AFNI. But that's terribly easy to set up as long as you can see the file systems. And then you see the images as they're collected. That's tremendously useful because the scanner itself shows the images great, but there's still a question of how they come out looking in a normal data set. So, for example, some people mess up at the scanner. These fields are in millimeters, this one's in centimeters. I forget, my field of view is not 240 millimeters, it's 240 centimeters. You're collecting images like this big, and the brain is this little area in the middle. And you get 3 voxels across in every direction. So that data is garbage. You'd like to see this at the scanner, right? And fix your protocol and collect it properly. Some people have gone through scanning and not seen this for months. Like 3 months of collecting subject data with this problem and not looking at the data, and that's just, now you've just wasted all that time and resource and money. So you want to see the images right away. So it's nice to have some setup at the scanner that enables you to do this. And the motion, seeing the motion right up front, you're moving a little too much. Just try to relax and breathe comfortably. Get your whole body as relaxed as possible, and try to move less. Okay, and just saying, of course you'll say this anyway. You just assume they're moving too much, but it's nice to see the motion parameters so you get an idea of actually how much they are really moving in the scanner, at least according to the estimates of the software. But so beyond that, at the NIH, they've automated this stuff. So they have scripts attached to the scanner so that when you hit scan, it actually controls launching AFNI on a remote computer. It controls running Dimon locally on the scanner and sending the images over. So at the NIH, the researcher doesn't have to think about this. They just say, okay, scan a new run of EPI, collect more EPI data, and then they see this automatically. no effort involved. So it's nice to have some setup like this. So just some food for thought. I don't know how your setup is. You can even set up AFNI for real-time feedback and things like that. So we've babbled about the command line programs, which we might call batch mode. Batch mode is like scripting or typing commands rather than clicking buttons in a GUI. Like I mentioned, there are quite a few programs in AFNI, and so there is an initial learning curve. So, but we have examples of how to do things. We just recently replied to one of Tom Nichols' preprints of some analysis, and along with our reply to that, or pre-ply, I don't know, we included examples of a full processing analysis, everything. So we've recently redone an analysis with a complete set of scripts, so you can use something like that as a sample starting place. But how do you learn all the individual programs? Just practice. Practice makes better, right? So do so. We have a lot of batch programs, a few examples of more than 100. So this shows you, this slide's a little dated. We have about 600 programs and plugins and models right now. But like 3D Deconvolve does linear regression with ordinary least squares. 3D RemelFit does uses Remel, an ARMA 1.1 model for the generalized linear regression. 3D Volreg is an ancient program, but it's very fast for doing EPI registration. This is what basically scanners were doing real-time registration using this software in like 1988. So it's built to be very fast. But of course, you don't care now because everything's fast enough. But anyway, that's what it is. Some of Gong's group analysis programs. Gong over there, most of his programs are written in R, but he still puts 3D something wrapper interfaces, so you're not running R directly. You just run them as if you ran any other program. 3D Calc, again, that's a calculator program. 3D Resample, you can change the orientation, how the data is stored on disk, change the voxel grid size, resampling, whatnot. Lots of programs. SUMA, AFNI, the little AFNI is the graphical interface for looking at volumetric data. SUMA is the graphical interface for looking at surface mapping data, surfaces. SUMA, you can actually look at volumetric data too. You can look at like correlation matrices, a sparse matrix of nodes in a data set that are that have correlations or whatever, some DTI measurement weights between them, whatever. You've got this basically a sparse matrix of data. You can show these in space, even connected to the surface and locations and rotated and all that. You can do wild stuff. Hopefully Daniel will have time to show you some of that at the end. SUMA teaser movie. This is especially a teaser because I can't show it to you. It was written. This is a PowerPoint presentation, and I'm using Linux, so I can't show everything right on here. I think that's enough for command line stuff in here too. Let me show you a couple more things before I move on to Dimon a little bit. In this directory, just so you see some of the other files that might be worth noting ahead of time, like this stim av1 viz.txt. That's a stimulus timing file. Just to give you a preview so it has a little time to sink in before we use it later on. These are just, this is a text file of numbers. It doesn't have to be integers. It doesn't have to be integral. It could be 0.716, whatever. But these are times of stimulus events from the beginning of each run. So this has 3 rows, there are 3 runs. So the first event of this AV1 Viz class, a visual class that will, visual stimulus event that we'll talk about, happened 1 minute into the first run, for example. So that's the most basic format of our stimulus timing files. And also in here is motion.1D. 3D volreg was run on this data to align each EPI volume to a base EPI volume. So taking this volume, aligning it, taking the next one, align it. And there are translations and rotations involved in that. And this motion.1D is just 6 columns of numbers that show the 3 translations and rotations around the axes. You don't usually look at it like this, but it is just a simple text file that we can plot. So 1D plot. So I'll show. That's a stupid thing. Let's add scaling in there. So I'll show this more later on, but so those are motion parameters. So just in another couple examples of what's in this directory. So let me leap over to let's talk about Dimon briefly. How many is your data acquisition here for the most part automated? How many people actually analyze data? Do you have to handle DICOM files, or do you go straight to NIFTI or something like that? How many people handle the DICOMs? Okay, most of you. So this might be worth chatting about a bit. Brooker? What do we use to do that? Those are PAR-REC files?
No, they can write DICOM with their Paradigm software. Remember, we did that with for the monkey scanner.
Mm-hmm. So do you get DICOMs out of that?
I take the raw Brooker file. Yeah, is there export DICOM?
No, the Brooker has this reconstruction part. We just use the.
So that's PAR-REC files?
No, it's not. PAR-REC is Philips.
Oh, Philips.
But they have their own structure, which is something a little bit like PAR-REC.
Uh-huh.
With the raw data and then we save it, like we write it as NIFTI.
Oh, good. Oh, from the scanner.
From a scanner,
Okay.
and then we write it, and it automatically generated the header file and has all the scanned information.
Okay.
So
For
it's all
animal
in
studies? Are you
Yeah,
using
this-
it for animal studies?
Yeah.
Rats.
Yeah, so rats and marmosets.
Yeah.
Yeah, so in your case, you may not have to worry about that. But if you're dealing with DICOM files, we do have a program that will collect them and turn them into data sets, AFNI or NIFTI if you want to.
Read for broker files, you can read directly into AFNI, but you need to put all the parameters manually.
Right. So 2.3, that's a pain.
So
Yeah.
the way we have it set up at NIH for our monkey scanner, which is a Bruker scanner, is we've automated this with Dimon and using the Paravision software to start a script that starts this Dimon software and automatically reads it in, because it's a pain for every one of the researchers to figure out exactly the parameters. And so Rick and my time was getting filled up with every variation of every experiment, and they actually write DICOM properly. I highly recommend using the Dimon software, and if anyone needs this script that we wrote, we'd be happy to provide it.
So you can go Brooker to DICOM.
Broker to DICOM, but you need this Paravision thing, which I think might be an option.
They weren't the ones writing NIFTI in real time?
They were not writing NIFTI in real time. Well, in the end, they were writing.
Because they
No, they were
didn't.
writing
They
AFNI.
wrote NIFTI or AFNI, and then we converted it. Dimon read that and then made.
No, we do it through their DICOM format. We're doing it Bruker's DICOM to AFNI format. Because what was happening was either people were writing their own MATLAB scripts, or they were writing their own 2,3D commands, and everybody was doing it individually and getting themselves mixed up about orientations, and rats and mice and marmosets were upside down.
Yeah.
And cactus. So I think I highly recommend this. This I think will be very interesting.
Yeah. So this. We're up. I'm up in the upper right corner here. So in AFNI handouts, AFNI 02, 2,3D. 2,3D is the oldest method. That was possibly the very first AFNI program. I don't know, because that program was used to create an AFNI data set. So that's kind of a prerequisite for using it. Yeah, but that predates AFNI.
It predates AFNI, but CCalc predates AFNI, yes.
So yeah, this was sort of necessary for obviously doing anything with the AFNI format. But now for the most part, we don't recommend using 2,3D unless you have to. So you can run 2,3D, or if you have DICOM files or even GEI files. Dimon stands for DICOM monitor. It was written to monitor incoming DICOM files at the scanner and send them to AFNI in the real time. But you don't have to use this at the scanner. You can just use it to assemble data sets. Or 2,3D, even if you just have raw data with 2,3D. But then you have to tell 2,3D the voxel dimension, the number of voxels, the orientation, the voxel size, not just the number, but how big each voxel is and stuff like that. So 2,3D is harder to use, but you can, of course, use it to take any raw data into a data set. But Dimon deals with DICOM files, say, or in real time. So for example, we have some DICOM files here under AFNI Data 6 EPI Run 1. So I guess I will not maximize this. So if you recall, just to give you a little more practice at the terminal here, we're in the AFNI Data 6 /AFNI directory because we CD'd into AFNI Data 6 and CD AFNI. So let's go, we want to go up one level to the parent directory, and the parent is called ... The current directory is a dot, which you occasionally need. If you want to copy some file here, you might copy it to dot as the destination and would put it in this directory. ... takes you up one level. So now you can see the prompt shows AFNI Data 6, as does PWD. And if I type ls, now you see the AFNI directory that we used to be in. Okay, so this slide, for example, here is babbling about EPI Run 1. So if I type ls on EPI, and if I just type the E or the EP, I can hit a tab and get file completion there. But if I look at the contents of this directory, it's got all these 8 HR brain blah 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 something.dcm files. So this has a bunch of DICOM files. So you can use Dimon, for example, to turn this into a data set. I don't know if I'll follow all the examples like this. I guess this one's okay. So I can use Dimon-infile. You can say infile pattern, and you can give a wildcard, or you can use infile prefix and say it's EPI Run 1. It starts with 8. All the files are named something starting with that. So I can give this as a prefix. That's an alternate usage. And I can just say GERT create dataset. There are a lot of goofy GERT options to Dimon. GERT stands for GE real time. So as with many things in AFNI, there's a historical background on why we use this stupid name for this stupid function, and you just have to, you get used to that. It's entertaining to some degree. So anyway, we tell it to create a data set out of everything that looks like this. So I hit enter, it finds a first volume so it actually looks at these slices and looks at the coordinates in them and until it finds something that repeats, and then it's checks to see if the coordinates of these slices match the coordinates of the first volume that it found, and it's looking for missing slices. It's doing a lot of error checking. That's the purpose of it. But in this case, we just want to create a data set. So after it goes through that, it actually writes a little script that has a 2,3D command in it, so that you don't have to figure out 2,3D. It's doing that. Mm-hmm.
So can we see the Dimon command, what's inside the script?
Yeah. So the Dimon command itself is this, and if I type ls now, or actually ls-ltr, the L is a long listing of the files, so it includes things like some permissions, or whether it's a directory, executable read permissions, the owner, the group, the size of the object, the date that it was last modified, and then the name of the directory or file. So LTR, L is a long listing, T sorts by time, and R is reverse sorting so that the newest stuff is on the bottom. So ls-ltr, we see the newest files on the bottom. So what did Dimon create? It created GERT Rico, another goofy name, GE Real-Time Reconstruction. That's just the prefix. This is actually a script that has a 2,3D command in it. Dimon files.run3, it found that these files had run number 3 in them, so it was the third scanner acquisition. But this is actually the list of the files that are this sorted list, because sometimes the alphabetical ordering of the files is not correct. You have to fix it. It may do so. And then outbrick is the name of the data set. If I look at the top 10 lines of this Dimon files, head shows the top 10 text lines. These are the first 10 files that went into the data set. But of course, there are thousands of them. There are 2,278 files that went into this run. It's 33 slices by 152 time points. And lastly, that script, if I look at that with less, or you can, I guess you can't type open on your Mac because open won't know that it's a text file. It won't know what to do. Since I don't know what editors you all have, we have an AFNI open, abusing the Mac command open. We have an AFNI form of it that says AFNI open-E on some text file. The E says to search my computer for some editor and use it to look at this text file. So on mine, it's
Which editor you prefer to use?
yeah. Use whatever you want to, but if you don't know, AFNI open-E will find something. Hopefully, it'll find something. But that font sucks, so I'm going to stay on the terminal window. So this is a tiny script. Basically just comments, setting a couple variables, and then a 2,3D command to create the data set. So this 2,3D command has the name of the output data sets, the sorting of the data, the binary data that it's going to convert is the Z coordinates are changing before time. That means you get slices varying over space first, and then a new time point. Slices, new time point with slices. That's the ZT, but you don't have to memorize this because that's Dimon's problem, not yours. I'm just showing you what it is. And then 34 slices, 67 time points. That corresponds to Z is 34, T is 67. The TR is 3 seconds. The Alt plus Z is that interleaved slice timing pattern. And then the names aren't on here. You could use a wildcard or something like this, but this is just saying to read the names from this file. Anyway, so that's the script that Dimon eventually runs with the GE RT create dataset option, and now you have that data set. Questions about this?
So if we run our own sequence and then the slicing is like the sequence is different, like it's not interleaved the default way, when we use the DICOM, do we have an option to change that?
Yeah, you can tell Dimon what the slice pattern is. You can say Alt plus Z2 or sequential, or what is it when it's all at the same time? I forget, but you can tell it all these things, and you'd actually get the help for those things in 2,3D. It lists all the slice patterns. Yeah, it's the same.
I think it's T0.
Yeah, T0. Yeah, that, or is that 3D T shift? I don't know. Anyway, so you can look it up and make sure of what you're doing. Any other questions about this? So let's get slightly more complicated. Oh, we're out of time. So I'll be quickly slightly more complicated. So here's there's also this DICOM T1 directory. If we run Dimon, maybe I'll just type myself in file pre DICOM T1. They all start with I, and try to create a data set. It fails. Why? There are multiple reasons in this case. One is that if you look at the files in this what directory? DICOM directory. Well, if you look at the names, this is just a random set of names that Bob made up, but often the names are not alphabetical. The alphabetical naming is just the scanner's choosing things in an asynchronous fashion and naming the files that, but internally it knows the right order. But if you look at them alphabetically, it might not go like this. It might be all over the place. So the alphabetical ordering of the names won't necessarily match, and you may have to tell Dimon to figure the ordering out. And there are multiple ways it could do so. But there is a most common way that it will try first, and then hopefully that works for the most part. In this case, the header, the DICOM headers inside these files, in this case it contains multiple information that disagrees with itself, multiple pieces of the same information that are different. So you actually have to give it extra options in some case to say work harder in some sense. In this case, we have to tell it to use last element. So in the DICOM header, it might list some information twice, and the last occurrence is the correct one. So this is use last element is saying to do that. And I can just say DICOM org. This DICOM org option is just telling Dimon to look at, it looks at one particular DICOM field, the relative instance number, I think, or something like that. See the help. And sorts on that and sees if it varies. So in this case, now, yes, it found everything. 171 slices. This is just an anatomical data set, so it's not multiple volumes. But found 171 slices, but they were sequentially ordered, which is to say the z coordinate was varying in a consistent manner. If it did not vary consistently, Dimon will whine about it and probably fail. But with these options, it works, and then you're golden. So if you were to use Dimon in your setup, what options would you use? I don't know. That's the sort of thing you have to play with a little bit and figure out. I can help you do that, but the DICOM headers vary drastically, wildly. Even within one company, they can vary, and then across manufacturers and across decades, it's a little unpredictable. So exactly what options you would need may depend. And some of your data doesn't come from here, right? You get it from elsewhere, and then the options will be different. So you have to think about this stuff. But this is one program you can use to create data sets. We also have the DICOM to DCM to NIX from Chris Rorden. We have an AFNI version of that, DICOM to NIX _ AFNI, just so there's no so it doesn't conflate with the one he puts out. But so that's another option. Any questions about this?